Okay, so now we're going to look at how changing concentration affects equilibrium. If we increase the concentration of the reactants, that's going to favor the forward reaction, or equilibrium is going to shift to the right. That's because if we increase everything over here, then equilibrium is going to shift that way to try and compensate. Equally, if we removed reactants or we decreased the concentration, equilibrium would shift back left, or it would favor the backward reaction. Same in reverse. If we increased the concentrations over here, it's going to shift equilibrium back left. If we decrease the concentrations here, then it's going to shift the equilibrium right. And that is the most common thing to do in industry. If you pipe off your reactants, your products as they're made, then the reactants are going to keep shifting equilibrium that way. So it's going to favor the forward reaction, which is exactly what you want to do in industry, because you want to make the most amount of products. So most often they remove the products as they're made. For example, in ammonia, when ammonia is a gas and they can just let the gas out. Also, we can, if it's a gas, only if you see gas. It doesn't work in solids or liquids, I'm afraid, but you can increase the pressure. Now, if you increase the pressure, the reaction will favor the side with the fewest moles. So you just add up how many moles are over here and how many moles are over here. Now, for those of you who are struggling to remember C6, moles is just big numbers. You just count the big numbers. So in this case, if there's no big number, it means 1 mole. So you've got 1 mole of A plus 2 moles of B. So 3 moles in total, 1 plus 2 on this left-hand side. On the right-hand side, you've got 2 moles. So in this reaction, for example, if you increase the pressure, you would favor the forward reaction, or we would say equilibrium would shift to the right. Again, whichever way suits you. Favor the forward reaction, equilibrium shifts to the right is exactly the same thing. So let's have a look at an exam question. This one again is about the contact process here. But again, even if we know nothing about the contact process, it really doesn't matter. We just apply the rules that we've learned. A low pressure, 2 atmospheres is used. At equilibrium, about 98% of sulfur trioxide is present. What is the effect on the position of equilibrium of using a higher pressure? Only 1 mark. So you literally have to state the effect. You don't have to explain it. And explain why a higher pressure is not used. So here, you need to give a reason for your choice because it says the word explained. Pause the video now and see if you get both marks. Okay, so hopefully you've got an answer. Here is the correct answer. If you used a higher pressure, then equilibrium would shift to the right. Or we could say it favors the forward reaction, because the increased pressure would favor the side with fewer moles. You only have 2 moles over here, but you have 3 moles over here. So equilibrium is going to shift right. Why then is a higher pressure not used? Why does it only in industry use 2 atmospheres? Well, you've already got 98% over here. So why would you need to put in extra money, extra time, extra resources? Why would you need better equipment to maintain the pressures? 2 atmospheres is enough. 98% is already a really, really high yield. So that's why you wouldn't use it. Let's have a look at this. This is a long question and it builds and it asks you to apply everything that you've learned so far. Nitrile chloride. Again, it doesn't matter that we don't know what nitrile chloride is. We just apply our rules. Reacts with nitric oxide. The forward reaction is exothermic. Underline this key point or draw an arrow and write exothermic this way, just to remind yourself. If it wasn't important, they wouldn't tell you. The reaction can reach equilibrium. What is meant by the term equilibrium for a reversible reaction? Pause the video now, come up with your own answer. It's 2 marks. You need to make 2 points. Okay, hopefully you've got your own answer. Here is the correct answer. Equilibrium is when the forward and backward reaction happens at the same pace or the same rate. it means that concentrations of both the products and the reactants do not increase. So you get the same amount of products and the same amount of reactants, the concentrations stay the same. Okay, building on this question, this is the same information from the top. Explain why increasing the temperature increases the rate of reaction. This is coming back to collision theory. If we increase the temperature, why does the rate of reaction increase? Now, don't be fooled into thinking it's because of exothermic. It's just talking about the forward reaction and the backward reaction. Both of them happen at a faster pace. This isn't about equilibrium. This is about collision theory. So 3 marks, which means 3 points. Pause the video now, come up with your own answer. Okay, so the actual answer for 3 marks. 1, particles have more energy. You can say particles have more kinetic energy if you want. They're moving faster, so there's more frequent collisions. They collide at a greater energy, so there's more successful collisions. So it's a 2-part. There's more hitting their activation energy, but there is also more frequent collisions. So it's a 3-part answer to this one. So again, the same information. See, it's building all the time. State and explain the effect, if any, of increasing the temperature on the position of equilibrium. This is where we are now talking about shifting the equilibrium. This is where this information is important. So if the forward reaction is exothermic, what effect will increasing the temperature have? Pause the video now and come up with your answer. So if you increase the temperature and the forward reaction is exothermic, increasing the temperature will always favor the endothermic reaction. So 2 marks. 1 for saying that very fact. Increased temperatures favor the endothermic reaction. The next for stating what the effect is. Equilibrium would shift to the left because the backward reaction is endothermic. What you're saying there is that you understand that the increased temperatures favor the endothermic, and you're then pointing out which way is endothermic. Building again, same information. State and explain the effect, if any, of decreasing the pressure. Add up the number of moles and think of what you're going to write for your 2 marks. Pause the video. Okay, welcome back. The correct answer is there would be no effect. Don't ever be fooled into thinking there is always effect. That's why it adds the if any here. No effect. Why? Because there is 2 moles over here and there is 2 moles over here. So we say the moles are equal on both sides. 2 marks. That's the end of this little bit. In the next video, we will be discussing how we measure rate of reaction. See you next time.